And let me thank the audience also for their interest in this topic, particularly at 9 o'clock on a winter morning. This, of course, is why we're all here, to celebrate Rachel Carson and her amazing book, Silent Spring. I remember reading this in the early 1970s, and it had a big impact on me. And strangely enough, actually, I reread it last year. I couldn't find my original copy, so I downloaded a Kindle copy. And this was actually several months before you invited me to give this talk, Jack. So I'm actually quite familiar with the book again, having read it recently. This was a hugely influential book. So I'm sure most of you know, in the sort of the decade following the publication of this book, most of the environmental legislation that really matters in the US was put in place. And within a decade of Rachel's book being published, we saw the Endangered Species Act in place, the Clean Air Act in place, the Clean Water Act, and the formation of the Environmental Protection Agency. It's a very, very far-reaching environmental legislation, and it's still today the basis for the environmental legislation in the US. Very little of importance has been added to these 4 key pieces of legislation. And Rachel Carson's book contributed in a really important way to the creation of a mood in which all this legislation was possible. I mean, for example, it would be impossible to get 1, let alone all 4 of these through Congress in the present environment, present political environment, that is to say. Okay, so that's a very worthy cause to celebrate, no question about that. So this is my agenda today. I want to talk about why biodiversity matters, fairly briefly. You could obviously run an entire course on that. Then I want to talk about how economists can think about biodiversity, and I want to talk about biodiversity as an asset and biodiversity as natural capital. From that, I want to go on to talk about some of the key economic characteristics of biodiversity, what makes biodiversity what it is, and what makes biodiversity in particular rather hard to think about from an economic perspective. Finally, I want to talk about monetizing biodiversity. Biodiversity is very important, has huge economic value. Can we turn that value into revenue? Can we monetize biodiversity? And I want to talk about briefly at the very end about public and private investments in biodiversity and biodiversity conservation. Okay, so that's the agenda. Start off from the obvious. Biodiversity is crucially important to all of us. Without biodiversity, we would not have come into existence. Without biodiversity, we couldn't even continue in existence. And I always find an interesting way of understanding this and getting a perspective on this is to compare the Earth with its immediate neighbors in the solar system, Venus and Mars, both of which obviously are completely uninhabitable. Venus is far too hot, Mars is far too cold, and neither has an atmosphere that we could live with. What's the key difference? Well, there's a number of differences, obviously, but one key difference is that the Earth has a 10,000 meter thick biosphere, which contains plants and animals. And this biosphere, the system that comprises this biosphere, moderates the temperature of the Earth and stabilizes atmospheric concentration and composition, both at levels that are conducive to our existence. So it's the existence of the biosphere, which is essentially the total of all biodiversity, which makes it possible for us to exist on Earth, which is the big differentiator from our neighboring planets. So biodiversity unambiguously matters. It's actually quite hard to define biodiversity and hard to model it analytically. We don't have any general theory of biodiversity or how it contributes to human well-being, either ecological or economic. That makes it sort of difficult to develop the economics of biodiversity, except in a rather case-by-case fashion. That's really what I'm going to be doing here. Now, biodiversity, of course, is being destroyed. You're all very well aware of that, I'm sure, but just to give you some rather depressing numbers. The US bird population, I'm a very enthusiastic bird watcher, so this matters to me. Now, the US bird population declined by about 3 billion or 30% between 1970 and 2010. So 40 years, 30% decline. The main driver of this is loss of habitat, of course. Been a huge drop in insect populations around the world, with the use of insecticides being a major cause here, although not the only cause. World Wildlife Fund reports that, reported in 2022, that on average, there'd been a 69% decline in the populations of mammals, fish, birds, reptiles, and amphibians since 1970. So in 50 years, there was a 69% decline in the population of most species. So a dramatic decline in biodiversity. So how should economists think about biodiversity? And we have to think about biodiversity basically as an asset, or perhaps as a series of assets, a collection of assets that generate flows of services over time. And we typically refer to these assets as elements of natural capital, and the services they provide as ecosystem services. So we have a model of biodiversity as essentially a collection of assets which yield a flow of services over time. And that incidentally is the definition of an asset from an economic or financial perspective. It's something that you can own or something you can possess, and that generates a flow of services over time. Now, taking this perspective enables us to employ a range of techniques and concepts from finance to think about biodiversity and to value biodiversity. In finance, it's conventional to value an asset as the present discounted value of the flow of services it produces. So if we see biodiversity as assets that produce flows of services over time, if we can value those services, we can value the assets. Of course, valuing the services can be very difficult. I'll talk about that later on. A word about different types of capital. Now, we're used to thinking about many different types of capital. And when you think about capital, first of all, you think, I guess, about built capital. So that's the capital we construct. That's the computer I'm talking to right now, the building I'm sitting in, the computers you're looking at, the buildings that you're sitting in, and so on. And that's perhaps the most obvious form of capital, but human capital is also very important. That's arguably as important these days. And human capital is the knowledge and skills that we acquire through education, through experience. And for many people, much of their income is really a return on human capital. Then there's intellectual capital, which is the sum total of everything we know. It's the knowledge which enables us to make these computers and to link them together over the internet and so on. So natural capital is another type of capital. It's an asset which yields a flow of services over time, and soil, forests, rivers, climate, different species. These are all examples of natural capital. They're all part of nature, and they all yield a flow of services over time. So let me give you some more detailed examples of biodiversity as capital assets. So soil is obviously an asset. It enables us to grow crops. Rivers are an asset in the sense that they enable us to generate hydropower. Oceans are an asset because they support fisheries. Genetic diversity is an asset, and I'll explain in more detail later on why genetic diversity is an asset. It's actually intellectually quite an interesting one. Forests are assets for many reasons, one of which is that they capture and store carbon, and they reduce the amount of CO2 in the atmosphere. Wetlands purify water. Watersheds provide drinking water. Insects and birds pollinate plants and provide the services of agriculture. So these are all examples of pieces of biodiversity which have the structure of an asset. They produce a flow of services over time. And I'll talk about most of these in a bit more detail now. So soil. You may think of soil as just dirt, but it's not. Soil is alive. The fertility of soil comes from the billions and billions of microorganisms in it. Now, fertile soil is clearly an asset, and it's actually valued as such by the land market. A farm will sell for a price that depends upon the fertility of their soil. And a farm with more fertile soil will sell for more per hectare than one with less fertile. So soil is obviously an asset, and it's an asset whose value is ultimately driven by the biodiversity embodied in the soil. Hydropower. So a hydropower station is clearly an asset. And it's an interesting asset because it's a mixture of natural and built capital. So the largest power station in the world is actually a hydropower station. It's the Three Gorges Dam in China. Produces 22 gigawatts of electric power, which is roughly, it's more than 2/3 of the total power consumption of New York State. New York State has very, very high levels of power consumption indeed. It's more power consumption than most countries around the world. So hydropower stations are very, very important. And as I said, they're a mixture of natural and physical capital. The physical capital element is obvious. It's the dam, the turbines, and so on. The natural capital element is the flow of water in the river and the geomorphology and the climate system that generates that flow. And rainfall, of course, depends upon the climate system and on vegetation via evapotranspiration. So we can argue that the functioning of a hydropower station is a function ultimately of some degree of biodiversity. Fisheries. Fisheries, again, obviously are assets. Oceans are a critical food source. In a number of poorer countries, the fish is the main source of protein. It's also a major source of coastal employment in many communities. And fisheries, like many other sources of biodiversity, are currently collapsing from overexploitation. Not all of them, but many of them. Bioprospecting. This is actually quite interesting. This is where we relate to genetic diversity. Pharmaceutical companies often find novel molecular structures by studying plants and insects that are chemically active. By chemically active, I mean that these plants and insects defend themselves against attacks or repair damage themselves or attack prey using novel chemical means. And this gives rise to the structure, to molecules whose structures are interesting and original, which can sometimes be adapted for pharmaceutical purposes. Interesting background fact here is that over 1/3 by value of all the pharmaceutical products sold in the US were originally derived from plants or animals. They're not today derived from plants or animals. Today they're synthesized, but originally they were derived from plants and animals. And classic example is aspirin. Aspirin is the most widely used drug in the world, one of the most important drugs in the world. And it actually was originally derived from willow trees. And it's been known, the fact that willow can act as an analgesic has been known to traditional healers for centuries, many, many centuries. And indeed, it's interesting that in the wild, you can observe gorillas when they're sick, medicating themselves by eating parts of willow trees. So even the gorilla population is aware of the bioprospecting value of willow trees. And recently, a number of other quite important anti-cancer drugs have been derived from plants. Forests and carbon capture and storage. So forests obviously capture and store CO2, and they're probably the most effective and the lowest cost method of removing CO2 from the atmosphere. There are companies like Climeworks, Carbon Engineering, you've probably heard of, and they have sort of mechanical mechanisms for removing CO2 from the atmosphere, and they will charge you about $1,000 to remove a ton of CO2 from the atmosphere. So if you go to the Climeworks website, they will sell you a carbon offset for, I think, around about €1,000 actually, just over $1,000. And it's costing them close to that to remove a ton of CO2 from the atmosphere. Now, forests can remove CO2 from the atmosphere for less than $5. And forests, in addition, have a vast range of co-benefits that Climeworks and Carbon Engineering don't. They're not just trees, they're the insects and the animals in them. And when you conserve a forest, you conserve biodiversity as well as removing CO2. Now, we can actually put a value on this in a very rough and ready way because we know roughly how many hectares of forests there are around the world. We know roughly how much CO2 each hectare absorbs per year. And it varies with the latitude and the type of forest, but we have that data. And we can put a price on the value of removing CO2 from the atmosphere. And that, of course, is the social cost of carbon. And if we do that, we can get a value for the flow of services that forests are providing through removal and sequestration of CO2. And then we can value them as an asset by taking the present discounted value of that flow of services. And it puts a value on the world's forests of somewhere between $50 and $100 trillion. To give a comparison, to get a sense of scale, US GDP is what, roughly 23, 24 trillion. World GDP is somewhere in the 80 to 90 trillion range. So this is a very, very big number indeed. Watersheds, maybe a little bit less obvious as an important ecosystem, but very important nonetheless. New York City, where I'm talking to you from, has high quality water in abundance with no processing at all, no filtration. It's thought of as organic water. It used to be the case that people bottled New York water and sold it as New York water in the way that we today sell Evian water as a high quality water. The reason for this is that the Catskills watershed, which is about 110 miles north and very slightly west of here, plays a very important role in purifying the water that comes to New York. Rain flows through the soil there. This process purifies the water and also smooths out the flow of water and effectively provides a very high quality, very highly purified water for the city. In the last couple of decades, New York City has invested about $3 billion in the watershed. That's invested in improving sewage systems, encouraging organic agriculture. And this is an investment which has led to investment in essentially in biodiversity conservation, which has led to cheap, high quality water. Pollination. Many of our food crops need pollinating. The really high volume crops don't. So corn, soy, rice, wheat, these have all been bred to be self-pollinating. So they need pollinating, but they pollinate themselves. but everything else needs pollinating by a third party. In particular, all fruit and all vegetables need pollinating by insects or by birds. Now, pollinators are dying out. I'm sure many of you read about the insect apocalypse, which is going on around the world. Populations of insects are falling very, very rapidly. We can actually place a value on the amount of food that we would lose if we were to lose pollinators and be unable to produce the food that requires pollination. And that's been estimated at roughly $217 billion per year. So that's the food produced by pollination. That was actually 5 or 6 years ago, so it's probably worth more than that today. Now, allowing for the fact that consumers are willing to pay more for the food than they actually do, this is the concept of consumer surplus. This is probably worth more. This food is probably worth more than 500 billion per year. And if you think of pollinators as an asset that produces a stream of value of $500 billion a year, then that asset is worth roughly $14 trillion. So you can think of birds and insects in their pollinating role. They have many other roles, but in their pollinating role as an asset that produces value to the extent of roughly $14 trillion. Finally, let me talk about genetic diversity. There's 2 types of genetic diversity which are important: variation between species and variation within species. We can talk about the second one first, variation within species. It's genetic variation within a species that allowed our ancestors to breed plants and animals selectively and to massively increase productivity. By taking, for example, types of corn to variants of corn that both which have very high yield, and crossing them, you can produce another one which has a high yield. So it's the variation within the corn population itself that makes that possible. And so the variation, genetic variation within the species allows this selective breeding, and it allows therefore a huge increase in productivity. Again, it's selective breeding that allows us to produce animals, cows, dogs, horses, and so on, with particular desirable traits. So genetic variation within a species is a very important asset. Actually, it's also important in another role, which is crop insurance. There's an interesting story which I think illustrates this nicely. About 30 years ago, maybe actually more than that now, 35 years ago, a virus called the grassy stunt virus started infecting the rice crop in a number of regions of Asia. First year, it destroyed about 5% of the crop. 3 or 4 years later, it was destroying almost 30% of the Asian rice crop. And it proved immune to all of the pesticides that could be thrown at it. So there was a real danger that it would destroy a very substantial fraction of the Asian rice crop. And people were very, very worried indeed about this. And eventually, the problem was cured, but the cure is interesting and relied heavily on biodiversity. There's an institute called the Rice Research Institute in the Philippines, which essentially stores seeds of early varieties of rice which are no longer commercially used, but which were perhaps used at some place in the world many years ago. And in the International Rice Research Institute, they found a variety of rice which had been used in India, a smallish region of India, about 40 or 50 years ago, but hadn't been used for a very long time. And it turned out that that variety of rice was immune to the grassy stunt virus. And so that immunity was then transferred over to commercial rice crops, and commercial rice crops are now immune to the grassy stunt virus. But that's an example of the importance of genetic variation between species and genetic variation within species as a sort of insurance against pathogens destroying our crop. And that's a real risk, incidentally, today, because we grow huge quantities of crops which are genetically homogeneous. So if a pathogen can attack one part of that crop, it can probably attack the entire crop. So crops today, with this huge genetic homogeneity, are actually very vulnerable to pathogens attacking them. So that was genetic diversity within a species. It's genetic diversity between species that enables us to engage in bioprospecting. It's genetic diversity between species that gives us a wide range of genetic and molecular structures to work with in designing pharmaceuticals. So let me summarize what I've said so far. What are the costs, the economic consequences of biodiversity loss? We lose a lot of crucial things. We can lose a lot of crops, the crops which require pollination. We can lose potential medicines. We can lose access to cheap, good, high-quality drinking water. We can lose access to insurance against pests and diseases. We can lose the capacity to develop new species and so on. So obviously there's a very real cost to loss of biodiversity, and biodiversity is very valuable to us. So the next thing I want to talk about is the economics of biodiversity. What are the key economic attributes of biodiversity? And in particular, what it is that makes biodiversity really hard to analyze in economic terms. I'm going to talk about four things. Two of them are on this slide: the fact that natural capital can last forever, and the fact that destruction of natural capital is irreversible. And two of them on this slide: the fact that ecosystem services are generally public goods, and the fact that we don't have really good models of how our policies towards biodiversity can affect human welfare. So, natural capital can last forever. So forests will absorb CO2 for as long as they exist. They don't depreciate in that sense. The Catskills watershed has provided high-quality water for New York City as long as the city has existed, and will continue to do so forever, provided we don't destroy it. There's no natural depreciation here. What this means is you have to think about very, very long time horizons when you're thinking about natural capital and biodiversity. It can provide value over very, very long time horizons. And that has some implications which I'll talk about in more detail in a few minutes. So destruction is irreversible. Again, a fairly obvious point. You can't generally recreate natural capital once it's destroyed. To coin a phrase, extinction is forever. Now, deforestation, for example, deforestation, particularly with tropical rainforests, is irreversible because it leads to chemical changes in the soil and to changes in the local climate, which will make it almost impossible to regrow the same forest again. Another example, quite germane to where I am at the moment, is that back in the 20th century, particularly the earlier part of the 20th century, the Northeast was Northeastern seaboard supported a huge cod population. And the cod fisheries here were very, very productive, employed a lot of people and provided a lot of very high quality food. Then the cod population was overfished and collapsed. For the last 35 years at least, maybe more than that, cod fishing has been very tightly regulated in the northeastern US, but the cod population has not rebounded. In spite of massive efforts on the part of the regulators to get it back, it hasn't rebounded. The cod population has remained depressed. And there were permanent changes in the structure of the ecosystem when the population collapsed, and they mean it's very difficult to get that population back again. So irreversibility. Public goods. Again, most of you know, I'm sure, what a public good is. There are two types of goods in economics: private goods, which are things like my iPhone here. If I'm using this phone, you can't use it. If I'm using this pen, you can't use it. So that's a private good. Only one person can use it. And there are public goods, which if they're provided for one person, are provided for everybody in a certain category. So, for example, if the government of New York decides to improve the quality of the air in the city, then that benefits me, but it benefits everybody else in the city too. So that's a public good. Now, knowledge is a classic public good. If I have a piece of knowledge, I can pass it on to you, share it with you, but retain it myself. You can pass it on to somebody else and share it with them, but then retain it yourself. So ultimately, we can all share a given piece of knowledge. So knowledge is a classic public good. Knowledge is what we get from bioprospecting. It's knowledge of molecular structures that we get from bioprospecting. The climate stability that comes from forests and from the sequestration of CO2 is a classic public good. The services of pollinators in generating fruit and vegetables are, again, a public good. And this has implications for how we can manage biodiversity, which I'll talk about in a second. Finally, we don't have good models of how our policies affect outcomes. We have what we call scientific uncertainty in this field. Central banks, for example, have reasonably well accepted models of how quantitative easing affects the macroeconomy. Investment banks have models which may or may not be good, but they certainly have models that they think are good of how fiscal policy or macroeconomic policy affects the stock market. For biodiversity conservation, we don't have any really strong models of how the policies that we can adopt affect human welfare. And this has some implications I'll talk about in a second. Finally, just as a point I won't develop much longer, but just mention that The dynamics of biodiversity is highly complex. Biodiverse systems have multiple regimes. When you write down the mathematics describing their behavior over time, they have multiple different regimes and tipping points associated with irreversible changes in the regime. So let me go through these points in a bit more detail. The first point was that the biodiversity implies long-term horizons because biodiversity in principle lasts forever. This means obviously that the choice of a discount rate when you're evaluating projects is crucial because conserving biodiversity can generate benefits 50, 100, 150, 200 years ahead. And if you use any conventional choice of discount rates, then the value of anything that far ahead is annihilated. So if you discount it, say 7 or 8%, which is conventionally done by governments and corporations, and sometimes more than that, then anything that occurs more than 30 or 40 years into the future is completely irrelevant and is discounted effectively down to zero. So we have to worry a lot about the choice of a discount rate and think very carefully about that. Now, if we're trying to evaluate the consequences of an extra increment of biodiversity at some point in the future, we need to discount that back to the present. And the discount rate we will use is what we call in economics the consumption discount rate, which any graduate student in economics will tell you is this number here. It's the rate of change of the marginal valuation of consumption over time. And if you do the math for this thing here, so U sub C is the marginal utility of consumption, and then this is the pure rate of time preference, and we're discounting the marginal utility of consumption back to the present of the pure rate of time preference and taking its log derivative here. If you do the math, that turns out to be equal to delta plus eta C dot over C. It's a standard formula again. Any honest student in economics will be familiar with this one. C dot over C is the rate of growth of consumption, and eta is essentially a measure of the curvature of the utility function. Now, that's the formula you get if you assume that well-being utility depends just on some aggregate consumption measure. But suppose that instead we recognize that utility depends on consumption and on some measure of environmental quality or environmental stock. So E is the state of the environment or some measure of biodiversity. In that case, if you go through this calculation here, you get a rather different expression. You get this one here, and this is the same as before in this term and in this term, but you get in addition this red term here. I won't go through the math, but just believe me, it's pretty straightforward. The implication of this, though, is interesting because it means that the rate at which you discount environmental benefits can be different from the rate at which you discount conventional consumption benefits, and in particular, it can be lower. It can be lower even than the pure rate of time preference, because this number here is quite likely to be negative. Okay, and that means that this number is likely to be quite small. So the right-hand side could actually be less than the pure rate of time preference. There's an argument for discounting future benefits at a very low rate indeed, if they relate to biodiversity or to environmental contributions in general. This is a controversial point, but I think these arguments are actually quite convincing. Irreversibility was my second point. The key thing here is that the combination of irreversibility of a decision, of a choice, uncertainty about the value of that choice, and the possibility of learning more about its value in the future, considerably raise the threshold for policy choices that damage biodiversity. They mean that there's what we call a quasi-option value or a real option value associated with the conservation of biodiversity. And this should make us a lot more cautious in conserving biodiversity. Put into relatively simple terms, it means that the expected payoff to biodiversity conservation, just in the expected payoff in the standard statistical sense, can understate the value of biodiversity conservation quite considerably because of the existence of this so-called real option value. And this is a diagram which goes through some decision trees to try to explain that, but I don't think I've really got time to go through this diagram here, but the slides will be available afterwards, and the economists in the audience can spend time on this, and they'll get the point. The third point I mentioned in talking about the difficulty in coming to grips with biodiversity from an economic perspective was that much of the services that biodiversity provides are public goods. And it's very well known that markets don't allocate public goods efficiently. Existence of public good is one of the classic cases of market failure. Why does this happen? Essentially because if I provide another unit of a public good, it benefits me, but it also benefits everybody else, because that's the nature of a public good. But if I think about this from a standard individualistic perspective, I only take into account the benefits I generate for myself, and I leave out the calculation the benefits that my decision generates for other people. So from that perspective, from that basis of that argument, we under-provide public goods from a social perspective. How can we resolve this problem? Well, there isn't actually an easy way of resolving this problem. There's a big literature on this, as you might expect. This is the incentive compatibility, incentive design mechanism literature. The key point here is that if I increase the amount of a public good, I benefit everybody else, but I'm not being rewarded for this. Effectively, I'm generating a positive externality for everybody else. And the way most of this literature works is by thinking about how to internalize the externality that I'm generating for other people. So the classic literature on this is what's called the Clark-Groves-Vickery mechanism for funding the provision of public goods. And what that mechanism does is essentially to pay me back for the benefits that I generate for other people when I fund the provision of a public good. But the problem with this mechanism is that it almost always ends up with an unbalanced budget and government expenditure exceeding government revenue. So it's difficult to actually think of applying this in practice. And there's a big literature on trying to overcome this problem, a very technical literature on trying to overcome this problem. But the basic answer is that there isn't a good solution. Of course, if people's preferences were somewhat different, the problem could be solved. If we were much more altruistic, much more empathetic than we actually are, then we might automatically take into account the benefits that our decisions convey to other people. So with sufficient interpersonal solidarity or empathy, public goods might be provided efficiently, but that's unfortunately not the world we live in at the moment. Another interesting approach here is what's called bundling public and private goods together. A good story to illustrate the importance of this and how this works is the safari business in Africa. Safaris in East and Southern Africa are a big business. What guests are paying for there, actually, in terms of private goods, is transport and accommodation. Transport in jeeps or Range Rovers or things like that, and accommodation in tents. And this is very expensive. You can pay $20,000 a week to spend a week camping in a tent, being driven around in a Land Rover or something like that in these areas of Africa. What is it that makes people willing to pay so much for this fairly substandard accommodation? And the answer is they're willing to pay this because of the presence of biodiversity. They pay this kind of fee so that they can see lions and leopards and elephants and giraffes and so on and so forth. And this is a seriously big business. I mean, there are several countries in Africa that get 20–30% of their export earnings from this kind of safari business. So a country that I've studied quite in some detail is Botswana. Botswana's principal source of revenue is diamonds. Botswana is the biggest diamond producer in the world. And roughly 50% of their export earnings come from diamonds, but another 30% comes from this safari business in the Okavango Delta in the north of Botswana. And what's happening is that the organizers there are not just selling tented accommodation. They're selling tented accommodation bundled with access to what people in that business call charismatic species. In other words, biodiversity. And the biodiversity, which is a public good, the presence of the biodiversity, raises the willingness to pay of individuals for that accommodation. So bundling a public and a private good raises the willingness to pay for the private good and can be good business. So it provides private companies with a strong incentive to conserve the biodiversity. There's actually a formal proposition you can prove there, which says that, for the economists in the audience, if utility functions are strictly concave, and cost functions convex, and a profit-maximizing producer who produces a private and a public good, and this is the key point here, and can practice first-order price discrimination, will provide an economically efficient combination of the public and private goods. So someone who can practice price discrimination can actually benefit greatly from bundling public and private goods together, and the incentive is sufficiently strong that he will actually provide the public good at an efficient level. That's a relatively rare case, but it does illustrate the importance of this concept of bundling public with private goods. That happens in Africa. It happens actually in other parts of the world as well. And I'll mention that again later. Last point I mentioned was that there are really no good models of how our policies affect biodiversity and how that biodiversity in turn affects human well-being. Effectively, what we've got is multiple different models of this relationship, from macroeconomic policy through to human welfare via biodiversity conservation. We don't know which of these models is the right one, or for that matter, if any of them is the right one. And in decision theoretic terms, this is we're looking at a situation where we've got what we call multiple priors, multiple different competing models of the same problem, multiple probability distributions over outcomes for a given policy choice. This is a big field in decision theory in the last 3 or 4 decades. And the growing literature on this suggests that there are 2 kind of dominant approaches. One is what's called the maximum expected utility approach, which derives from a paper by Gilboa and Schmeidler in Econometrica in the late 1980s. And their approach suggests that you evaluate a policy according to the analysis of the model that makes it look worse. So you take, for each policy, you take the worst possible case, and you evaluate the policy according to the worst possible case. Another approach, due to Klebanov, Marinach, and Mukherjee, known for obvious reasons, sort of the KMM approach, evaluates choices by sort of essentially a non-linear weighted average of outcomes according to the different models. But what's interesting about both of these approaches is that they both involve a considerable degree of focus on the worst case outcome. So, evaluating policy in a context like this, you're not certain what the outcome will be from your policy. You focus on the worst case, or you put a lot of weight on the worst case. Not unlike what the Europeans call the precautionary principle, which has been widely invoked in environmental conservation in Europe. One of the biggest obstacles to conserving biodiversity is the fact it's very hard to monetize. It's very hard to make money out of biodiversity conservation. That is largely because it's a public good, but also because it's intangible, and because of a lot of uncertainties associated with it. And bundling, as I've just been talking about, is in some ways an attempt to monetize that biodiversity. Biodiversity in this respect is rather like the climate. A stable climate is crucially important, but it's hard to monetize a stable climate, how to generate benefits from climate stabilization, generate financial benefits from climate stabilization. What can we do to conserve biodiversity? Well, currently most policies are government policies, and they're policies such as establishing conservation areas, establishing habitat protection legislation, establishing legislation such as the Endangered Species Act, or that's in the US and the European Union. We've got the Bird Directive, which is an equivalent piece of legislation, but for birds. We can limit trade in endangered species, which is what CITES does. Something we don't do, but we certainly could do, is harm activities, tax activities that harm biodiversity, taxing development of wilderness areas, taxing the use of pesticides, and so on. That's a kind of classic economic response to harmful externalities. There is a small amount of private financing of biodiversity, but to date, most of the biodiversity conservation has been financed by governments. But we're beginning to see a smallish number of socially responsible investors who are willing to invest in supporting biodiversity and willing to sacrifice some return for this. By that, I mean that if they normally look for, let's say, a 10% return on their investments, then if they can be convinced that the investment is supporting biodiversity, they might be willing to take, say, a 5% return. But still, they're looking for some return, so it requires some monetization of the benefits from biodiversity. And essentially, there are 2 mechanisms for monetizing biodiversity. One is the bundling that I've just been talking about. That's ecotourism. And ecotourism isn't confined to Africa. There's actually quite a lot of ecotourism in, for example, Costa Rica. Costa Rica generates a lot of tourism based on ecotourism, more there on birds than on charismatic species. Even here in the US, I mentioned earlier on I'm a keen bird watcher, and a lot of people go bird watching in Texas. Texas and southern Texas in particular is a real hotspot for interesting bird species. And that generates a lot of business for hotels, restaurants, and so on in southern Texas. So, bird conservation has a financial payoff in that part of the world. It's also the case that in many cases, one of the effective ways of conserving biodiversity is to conserve tropical forests. And tropical forests are very rich in biodiversity. And if you conserve tropical forests, you're of course conserving things which capture and store carbon dioxide. And you can use that to generate carbon credits. So the monetization of biodiversity so far relies either on ecotourism or on the generation of carbon credits from forest conservation, both of which are occurring on a relatively small scale at a global level, but at a growing scale. Okay, I said I'd talk for 45 minutes, and I've spoken for just under 45 minutes now, so I think I'd better skip to the end and give you some chance to ask questions. So let me summarize what I've said so far. Biodiversity really matters to the economy and to society as a whole. Many of its services are public goods, and so they're very hard to monetize. We are beginning to see a limited monetization of biodiversity services and some interest in biodiversity as an asset. Okay, so thank you very much for your interest in this, and I'll stop talking at this point and take any questions that are available.
Yeah, thank you so much for this fantastic lecture, and it's very insightful and stimulating. And now it's time for questions. The audience, again, is welcome to post questions in the Q&A box. And I have also received some questions in private, but I can ask you later. And there are already a couple questions in the Q&A. Maybe you can address those first.
Sure, yes. Happy to see a question there from Bill Clark. Hi, Bill, how are you? Nice to see you. Well, I don't actually see you, but nice to know you're there. So your question is, you argue that natural capital biodiversity can last forever, doesn't depreciate, as long as we don't destroy it. Yeah, there was a slight overstatement. I was simplifying things a lot, but you're right. Doesn't this perspective risk undervaluing the importance of investing in the maintenance of biodiversity and its ability to generate a flow of valuable services? Yes, absolutely. And in fact, when I talked about the New York City watershed, I did mention that New York City has spent about, I think the number was $3 billion in the last few decades in essentially maintaining the biodiversity of the Catskills watershed. So that hasn't been free, but the $3 billion is a lot less than we would have had to pay in order to provide an alternative source of this water. And yes, absolutely, forests need to be maintained. And there's many aspects of that maintenance, and that doesn't come for free. But the costs of maintaining generally are quite small relative to the benefits generated. So to a first order approximation, perhaps the simplification I was making was justifiable. So another autonomous attendee, what are the other important kinds of natural capital in addition to biodiversity? They ask because of the habitats of many nature advocates to silo their concerns, arguing, for example, that natural capital equals biodiversity or climate or minerals or unpolluted air. Those are all really natural capital. I've been focusing, I guess, primarily on what I should have called living natural capital. But obviously oil reserves are a form of natural capital. The diamonds in Botswana that I mentioned are a form of natural capital. But their dynamics are rather different, and the way in which they contribute to human well-being is rather different. Climate is a form of natural capital, but climate is, I think, in some sense, a derived form of natural capital. It's a secondary form of natural capital derived from other forms of natural capital. It's derived from the forests and from the oceans and from animal populations and microorganism populations and so on. So the climate is something which we generate from other forms of natural capital. Another question here is, once biodiversity is able to be monetized, how do we prevent exploitation? Good question. Property rights in biodiversity are hard to establish. And that's actually one of the problems with bioprospecting, for example. One of the reasons that bioprospecting has been hard to sort of regulate and manage properly is precisely that the property rights in these sort of intellectual ideas that come from bioprospecting are very hard to manage. And there has been some inappropriate use of those by pharmaceutical companies, and that, I guess, is the kind of thing you're referring to as exploitation here. So you need a regulatory framework, and there aren't very many good examples of that, but there is a regulatory framework which is coming into place for the ideas generated by biodiversity, by bioprospecting. But I guess that framework will be different in different cases. In the case of ecotourism, for example, the land is generally owned, and that prevents overexploitation in many ways, because what's happened in Africa actually is quite interesting. That in southern Africa in particular, a lot of the land which is now used for safaris used to be cattle ranching land, but the returns to cattle ranching were fairly minimal, not a good place to grow, to breed cattle. And the farmers there suddenly discovered that if they took the cattle off the land, took down all the fences, and allowed wild animals to return, and indeed encouraged the breeding of wild animals and repopulated the land with wild animals, they could then sell safari companies the right to bring safaris across their land and make a lot more money out of this than they did ever from cattle ranching. So that's been the principal driver of the growth of ecotourism in southern Africa, in Botswana and Namibia, for example, and South Africa as well. In that kind of context, because the land is owned by a single individual, the risks of overexploitation, I think, are quite small. Another question here. If a species from one location could do a better job at providing an ecosystem service in another location, should we introduce the species to the new location? Boy, it's a question I frankly never thought about. Species from one location could do it. It's an interesting question, and I'm afraid I don't really know the answer to that. Raises all kinds of questions about introduced species, alien species, and so on. So one have to be very careful about moving a species from one location to another. Another question from Jason Julian. Expanding ecotourism could expand protections, but has social economic impacts, usually negative on the local population. How do you weigh these trade-offs? Yeah, there are certainly trade-offs you have to worry about. In the case of southern Africa, the companies that run safaris there have generally been quite good at trying to involve the local populations. I actually spent quite a bit of time studying safari business in Botswana and in Namibia and South Africa. And the dominant company there is a company called Wilderness Safaris, which was actually formed about, I guess, 40 years back now, by two conservation biologists who had the very smart idea that they could make a lot of money out of managing ecotourism. That money could then be reinvested in conservation. And they have, in fact, done exactly that. And they've made a lot of money out of wilderness safaris, and they invest most of that money in conservation. And then one of the things they've made a point of doing is trying to involve the local population as the labor force in the camps that they set up. I remember visiting one of their camps in the north of Namibia, very remote area, where there's the local population of what are called the Himba people, and they live in they used to live in a very backward way. But the Himba people are now the people who work on the camps there. And I remember talking to a guy there who was a Himba, a guy in his late 20s, early 30s, I guess, had gone off to the main town to get a training as an engineer. And then I was back, and he was servicing the vehicles in the camp there. And he was explaining how hugely better off he felt than his ancestors, because of the fact that there was this tourism business, and he had the opportunity to get training and to live a sort of a much more sophisticated lifestyle than the original lifestyle that people there lived. But you do get problems of this sort, for example, with forest conservation. I'm heavily involved in rainforest conservation, and it's crucial in rainforest conservation to take into account the interests of the people who live in the forests. I am the chairman of the board of a group called the Coalition for Rainforest Nations. And this is a coalition of most of the countries in the world that have large tropical rainforests. And the guy who runs that on a day-to-day basis is actually from Papua New Guinea. And he actually grew up in a forest in Papua New Guinea, grew up in a treehouse 50 feet above the ground. As he tells me every day, he used to go out when he was hungry, he had to go out and catch something to eat or find something to eat. Now people like that can easily be neglected and overlooked when you're making grandiose plans for forest conservation. So that's a very important point, I think. Another question here. How the uncertainty is modeled for biodiversity with the worst case approach is used by others. I mean, the key point I was trying to make there, and I apologize for the fact I went through this very quickly. The key point I was trying to make there is that we have many different possible models of the relationship between government policies on the one hand, biodiversity conservation, and the impact of biodiversity conservation on human welfare. There's multiple different models, and we really don't know which is the right model. So we might have a probability distribution over these models. And each model itself might be stochastic and might give us a probability distribution over outcomes. So there's two types of probabilities. There's probabilities conditional on a particular model being the right model, and there's probabilities of a particular model being the right model. And those are the natures of the uncertainty there. And when you take all of that into account, it ultimately recommends a very cautious approach to conservation. Very important to conserve what you've got. Destroy it only when you're totally convinced and the argument is absolutely overwhelming. So it's what the Europeans call the precautionary principle. Scott Swinton. As you noted, biodiversity services are generated in complex systems. The monetary valuation, you pointed to ecotourism and carbon credits. Do you have pointers about the modelling of mixed ecosystem services such as conservation areas and farmlands that provide habitat for pollinators and natural enemies of ag pests, and of course sequester carbon, but which may also harbour ecosystem disservices such as habitat for ag pests? What are the promising directions in modelling values of services from these complex ecosystems? So if you're dealing with agriculture, you've got that's slightly different from any other ecosystem services because there is a market. There's a market for farms and a market for farmland. And if a farmland can be shown to be harboring a lot of the natural enemies of ag pests, then that makes it more valuable as a farmland. So there could be a payoff to the conservation of the type which encourages the enemies of agricultural pests. At least as there's a payoff to conservation of soils or improvement of the quality of soils. Now, I haven't really studied that in a lot of detail, I'm afraid. This is an interesting area and one which I think could benefit from a lot more research. And so I can't really say an awful lot more than that. I think you've raised an interesting question here. Elizabeth Breaker, and I see it's 9:59, so I guess this is better be the last question. You mentioned a premise at the beginning of your talk. If biodiversity is an asset, it can be owned. If this is an assumption underlies the idea of monetizing biodiversity, how do we reconcile this with the personhood and legal rights for ecological features, e.g. lakes and species? Yeah, I said owned. I was talking rather loosely. It actually can't be owned. And that's one of the problems in some sense. It's much biodiversity is what we'd call a common property resource. It's a common access, and it's very hard to limit access to it. That's part and parcel in some sense of being a public good too. Public goods are things that are generally hard to own. The examples I gave you, the example I gave of, for example, of ecotourism is a case where the underlying land is owned. And so there is some possibility of owning the source of the ecosystem services. Carbon credits, again, the carbon credits are generated by land, by forests. That may be owned. It's not always owned. And I talked about rainforests, and rainforests are actually often not owned by individuals. They're sort of commonly owned. In Papua New Guinea, where my colleague comes from, the rainforests are essentially the properties of communities. They're not owned by individuals at all. But a particular community, a particular ethnic group owns a particular rainforest, and that ownership is actually enshrined in the constitution of the country. There's some potential for owning ecosystem and natural capital, but a lot of natural capital really can't be owned. How do we reconcile this with the idea of personhood and legal rights for ecological features? Those, I guess, would be things that that's an interesting question. I don't really think I can answer that, I'm afraid. Goes a bit outside my field of expertise. I'm familiar with the possibility of personhood for animals of some sorts in that context, but I'm not really too familiar with the possibility of personhood for ecological features, and I haven't really thought through that very much. Interesting question, though. Okay, Jack, I noticed that I've overstayed my welcome by 1 minute, so let me stop at this point.
All right, so thank you so much. This is really fantastic. And also thanks to the audience for participating in this lecture so actively. There are many other questions. Unfortunately, we run out of time, so we have to stop here. But appreciate everybody's time, and especially Professor Hill for this really insightful and stimulating lecture, and which will inspire us to think about this kind of really important issues for around the world. I think, thank you so much. And again, goodbye, everyone, and enjoy the rest of the day or evening or depending on where you are. And so thank you so much again. Yeah.
Thank you, Jack. Thank you. Thank you, everybody. Thank you.
Yeah. Great.